Hi everyone. In this session, I am going to discuss the insertion operations. Insertion operations in a double linked list at three positions. One is insertion at beginning, insertion at end, insertion at a specific position. I hope you have already watched my previous videos because that will help you understand this topic more easily. So, double linked list. First, I will create the nodes one by one. So, this is my node n1, node n2, node n3, node n4, node n5. I will write the address of these nodes 1000, 1100, 1200, 1300, 1400 for example. So, always first one is none, last one is none, because there is no previous node here, there is no corresponding node. Okay. So, here this is n2, this field is previous, this field is next, so that you will write this address here, that is 1000 is here, you will place it, that is n2 dot previous is equal to n1, n1 dot next, this field is next, so n1 dot next is n2, so n2 is nothing but 1100 address, so 1100. So in this the data is 10, 20, 30, 40, 50. Similarly, you will write this n3 address is here, you will place n2 dot next is equal to 1200. n3 dot previous, this one is previous, n3 dot previous is equal to previous, that is n2. So what is the address of n2 is 1100. n3 dot next is equal to n4, n4 address is 1300. n4 dot previous is equal to n3. What is the n3 address is 1200. You will write 1200 here. n4 dot next, this field is next. What is n4 dot next is n5. The address of the n5. What is the address of the n5 is 1400. You will write 1400 here. n5 dot previous. So that you will write the address of the n4 is 1300. Here you will write 1300. Here no need to write anything because last node is next is none. So here the links are formed like this. One link like this, another link like this, because it is a double linked list. One link like this, another link like this, one link like this, another link like this. Here, if you observe, I am going to create a node here at beginning. So insertion at beginning, insertion at beginning. For that, I am going to create a node like this. Say 5. This one is 5. Always first one is none, none. So I am going to create a node. For that, I am going to write here new node at beginning. N and B is equal to, how to create a node of data. Here the data is 5. So what is this one? Data. Okay. Here always first node refers to head. That is fundamental concept. Self dot head. Self dot head. Here I will take the help of temp. I will take the help of temp. I am going to insert this node at the beginning. So for that I have initialized this temp from this head. So for that now this is my temp. So for that I am going to write temp is equal to, it is pointing to the self dot head. Always first node is self dot head. Always the first node refers to self dot head, either single linked list or double linked list. Immediately this is made temp. So already this temp dot previous is none. Now I am going to, this node name is NNB, new node at beginning. So temp dot previous is none. Now I am going to replace this temp dot previous is NNB. So here temp dot previous is equal to NNB. So that I am going to erase this one and I will write here NNB. NNB is nothing but the address. For example, here the address is 500. So that I am going to write here 500. Now one link is formed. But what happened at NNB dot next? Here it is a none. NNB dot next is none. So that here if you want to remove this, so now I will change this none with the address of the corresponding node. What is this corresponding node address is N1. So that here uh, we don't know whether it is N1, N2 or whatever it is. Always first node is self dot head. Self dot head is refers to temp. So that here I am going to change NNB dot next is equal to temp. So that here none is removed. What is temp address is? Simply 1000. So you will replace with 1000. Okay. Now another link is created. But you always remember, always in any linked list the first node is head, but still it is self dot head is in the second position. So you will remove the self dot head from this position to this position. Self dot head. How to move it? Just write one more line. Self dot head is equal to NNB. That's it. You will write these steps to insert a node at beginning. Now we will discuss about the insertion at end. For that I am going to create a node N at end E is equal to node of 60. It's nothing but data. Okay. So whenever you will write this line, one node is created here, that is with the data of 60, none and none. Something address is 1500 here, for example. Okay. Again you will use the help of temp. You will use the help of temp. So again you will start your temp from the first node. Always first node is equal to self dot head. So you will move your temp. So for the understanding purpose I will remove these points. Okay. So this is my first node. First node is self dot head. So self dot head is refers to temp. Here temp is equal to self dot head. Now I am going to move this temp to this position. For that here I am going to write a statement. Temp is equal to temp dot next. Okay, you will move your temp up to while temp dot next is not none. Okay, so temp is equal to temp dot next. Here what is temp dot next? Temp dot next is 1000. 1000 is here. Now temp is moving from this position to this position. Temp. Again, while temp dot next is not none. While temp dot next is not none. So here temp dot next is 1100. It is not none. Again temp is equal to temp dot next. Now it is moving to next node. Again temp dot next is 1200. Again it is not none. Move to the next node. Temp. Again temp dot next is not none. 1300. So again it will move to the next node. Temp. Again temp dot next is not none. 1400. Again it will move to here. Temp. Okay. Here temp dot next is none. So it is this loop is break because temp dot next is none. If it is not none, it will move to the next node. Temp is equal to temp dot next. But if it is none, it will come out from the loop. So then what we will do is this node name is NNE. I already told you, new node. So you simply write temp dot next is none. In this none, you will remove this none, you will add this address. What is this address? NN is 1500. So for that, temp dot next is equal to NNE, new node at end. So remove this one. What is the address? NN is 1500. So one link is formed. Similarly, this NNE dot previous is none. Now we will replace this none with the previous node. What is that node is? Temporary. So the temp node. So that NNE dot, this field is previous, this field is next. So NNE dot previous is equal to none. That none is replaced with the temp. So here remove this none, add. What is the temp is 1400? You will write 1400. So that one more link is added. Okay. But at a specific position, insertion at a specific position. So for that I am going to insert a node at here. So that is say 25, none, none, N N P, say N N P. Here we two important fields is, one is position, another one is data. Suppose position is 4, data is 25. 1, 2, 3. I am going to insert at the fourth position this node. So for to create a node, NNP is equal to node of 25. That is nothing but data. This is nothing but data. Again I am going to use the help of temp. It is starting from the first node. So this is temp. So how to point this temp? By writing a step, temp is equal to self dot head. Okay. So for this I am going to write one loop, for loop. Already I have explained in single linked list. You will go through those videos. For I in range of 1 comma position minus. So you will move your temp from this node to this node. For that, simple step, temp is equal to temp dot next. Temp is equal to temp dot next. So what is the range? Here range is 1 comma position is 4. 4 minus 1 is 3. So I is starting from the 1. So for that I is equal to 1, I is equal to 2, I is equal to 3. So here 1 is less than 3. Loop satisfied. Immediately temp is equal to temp dot next. Here temp dot next is 1000. Now this temp is moved to here. Temp. Again I is equal to 2, 2 less than 3, true. Again temp is equal to temp dot next. What is temp dot next is 1100. Now temp is moved to 1100. Temp. I is equal to 3, 3 less than 3, false. It is exit from the loop. So now what we will do is, here this is your temp position, here this is your node position. Simply this is your node nnp. In this nnp dot previous is none. Now nnp dot previous is replaced with the address of the temp. So here nnp dot previous is equal to address of the temp 1100. You are not supposed to write 1100 here, so that the name of this node is temp. So that here you will write temp. What happened immediately? This none will remove. Temp address is 1100. So 1100 is stored here. 1100 is stored here. So automatically one link is created here. Okay. Next, nnp dot next is again none. So nnp dot next is equal to here none, but you want to replace with the corresponding node address. Here the corresponding node address I don't know, but the corresponding address node is temp dot next. Here temp dot next is 1200. Temp dot next is 1200. What is the 1200? 1200 is the corresponding node address. So that you will write here 1200, but you will not write directly 1200 here. So you will write temp dot next. Temp dot next is 1200. So this is the corresponding node address. So that here you will write temp dot next. So remove this n. What is this address? Temp dot next is 1200. Here 1200 is added. So one more link is created here. Okay, but still if you observe here in this node, this is the previous node address. Now previous node address is not temp, this one nnp. But how to store this address? How to get this? How to get this 1100 in this place? This place is previous. Whose previous? We don't know whether it is n3, n4, n5. I don't know. But this one is nothing but temp dot next, because temp dot next is 1200. This address is 1200. So this node belongs to temp dot next. So here you will write temp dot next dot previous is equal to your new node nnp. Now what happened here? 1100 is removed. For example, you will say this address is 1150. So you will write here 1150 with this statement. Temp dot next dot previous is equal to nnp. So another link is also formed. Okay. Now what is this temp dot next is? Still it's showing the 1200. So you will change this 1200 by this address. What is this address is? 1150. You will write 1150 here, but in the code how to write? Simply temp dot next is equal to 1150 is address of the nnp, that is your new node insert at that particular position, that is nnp. So these two steps you will write in a systematic manner. If you write these two steps here, the code will change. Okay, so be careful while writing the steps, you will follow the steps. So one more link is formed. So at this position this will be inserted. Okay, so with this now I am going to implement this insertion operation in the Python. Okay, so here this is already the earlier double linked list code. So now I am going to create one more node here, one more node n, already created node n1, n2, n3. Now I am going to create n4. n4 is equal to node of 40. Here n4 dot previous is equal to n3, n3 dot next is equal to n4. Similarly I am going to create one more node, n5 is equal to node of 50. So n4 dot next is equal to n5, n5 dot previous is equal to n4. Once execute, so you will get 10, 20, 30, 40, 50 nodes. Now here I am going to write one more function, that is insertion beginning, insertion underscore beginning self comma data, insertion at beginning. Okay, simply see here nnb is equal to node of data, nnb is equal to node of data. I will pass the data while calling this function. Okay, enter. Next step, temp is equal to self dot head. So temp is equal to self dot head. Okay, again temp dot previous is equal to nnb. Same lines here I am writing. Observe, nnb dot next is equal to temp. Again self dot head is equal to your new node always at beginning, so always the first node is a head. Okay, next define insertion underscore and self comma data. Same steps. I am going to write these steps here. Okay. NNE is equal to node of data. NNE is equal to node of data. Temp is equal to self dot head. Here, while temp is equal to not none. So, while temp dot next is not none. If it is not none, then go to temp is equal to temp dot next every time. If it is not, if it is false, exit from the loop. Temp dot next is equal to new node at end. New node at end previous is equal to temp. Okay. Next, at a specific position, insertion underscore position, self comma position comma data. Same you will write nnp is equal to code. Follow these lines. nnp is equal to node of 25. Okay. Again, temp is equal to self dot head. For I in range of 1 comma position minus 1. Okay. Again, temp is equal to temp dot next. Exit from the loop once it reaches the target node. So, write these 4 steps in the Python. nnp dot previous is equal to temp. nnp dot next is equal to temp dot next. Temp dot next dot previous is equal to nnp. Temp dot next is equal to nnp. Okay. Now I will call one by one. So first of all, I am going to call this insertion at beginning. Copy this one here somewhere. Enter dll dot insertion at beginning with 5 suppose. Now execute. Yeah. See option. New node at beginning 5 is inserted. Suppose if you copy this statement, enter, control V, you will give 3. Again run 3. So okay. Now I will give comment. I will run the next lines. What is that? Insertion at end. Copy this one. Here I will write dll dot insertion at end with 60. Check it. Run 60. Okay. Similarly, copy this one. Control C. Enter. Control V with 70. Run it. 70. Now we will insert at a particular position. For that, copy this one insertion position. Okay, enter dll dot control V position 4 comma 25. Run. See, observe 1 2 3 4th position. It is filled with 25. Okay, if you give 3 here, run. So 10, 20, third position, 1, 2, third, 3, third position. So in this way you will write the insertion operation. Insertion operation. Okay. So if you want to check it, run. So only these 10, 20, 30, 40, 50 is there. Suppose I am going to remove this comment. Now run. Observe. 25 is added here. Okay. If I want to give comment, if I remove this comment at beginning, 5 will be added at the beginning. See. So like that you will implement your double linked list. You will implement the double linked list. Okay. So you will compare single linked list code and double linked list code side by side. There are only few steps will be changed compared to single linked list and double linked list. Okay. With this I will stop this session. In the next video I am going to explain how to delete a node, how to delete a node from the linked list. Okay. Thank you.